Alright, so today we are going to be going over the introduction to limits. And before we get into that, I kind of want to give you guys a real world example of kind of how limits work. It gives you an idea. It's a good way to get started. So think of this as a finish line. Don't mind the handwriting for now, it's a very small space. And here's your racer, right? So here's this guy, a little butcher drawing as well. Can't go wrong with that. So as you can see, there's a racer here, and just like every racer, they are trying to approach a finish line, a certain point. So here we go. So this racer is approaching a finish line. And where is he approaching? This finish line. So we're trying to find the finish line, essentially, and where he is going, right? So let me get rid of this very quickly. Alright, so before we get into this actual graph and visual representation here for that function, it's good to know the actual notation of how limits are written, you know, within a calculus setting. So a limit of a function, right, as x approaches a certain number, right, that is what the limit is. Okay, so here we go. So here are some practice problems essentially in relation to this graph over here. So over here you can see the limit of f of x. Here's we can write f of x. This is the graph, this whole function. The limit of f of x as x approaches -2. So you might think that, okay, so here's -2, x is approaching a certain value of -2, okay, it's got to be 1, right? Well, that's actually incorrect. That is in regards to one-sided limits, when we'll be going over that later in this video. But when we're talking about just limits in general here, we want the function to actually behave towards a certain point from both sides, right? So this one actually does not exist. And on to this next point right here, -1, right? So as the function approaches -1, it's kind of the same concept. You see, okay, both sides, it's approaching -1 from both sides, but they need to meet at a point. So as you can see, you know, this kind of discontinuity, it jumps, right? So they're not really behaving towards the same point. This is, you can see this is going to 1, and I don't know, maybe you want to count this as like -1 or something of that nature. But the point is here that this one also, the limit does not exist. And once again, we're going to be going over one-sided limits, and we can actually figure out what those are. But for now, the limit does not exist. Onto this next problem here, the limit as x approaches 0, so that's this right here. As you can see, that is -1, because from both sides, from the left side and the right side, it is arbitrarily behaving towards -1. So as the limit as the function approaches 0, obviously for x, equals -1, right? It's that -1 there. So, you know, at first we didn't really find any limits, but here we kind of had our first example of what a limit is. So over here, limit as the function x approaches 2. So over here 2, you might be thinking, okay, well, this is discontinuous as well because there's a hole, but you got to remember, we only care about where it is approaching and the behavior of that that function of where it's approaching. So we don't really care for now of the actual point, as long as they're both behaving towards that same point. So a hole is okay. So it's approaching 0 at 2. So over here as well, 0. So the limit as x approaches 2 for this function is 0. So for this one right here, we have the limit as x approaches 3. We go up, 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 and we approach 3 at 1, but kind of like the previous example, it jumps, and from the right side it approaches 2 actually. So from the left side it approaches 1, and from the right side it approaches 2 for x approaching 3. So that's another example of the limit does not exist. Okay, so now the next example is as it approaches 4. So the limit as x approaches 4, but hold on, we have this point right here. What do we do with that? So if you remember from earlier, we said we only care about what the function approaches, right? We don't care about the actual point. So even if there's a point, right, f of 4, right, also equals 0, we don't care about this actually. We only care about what it's approaching. And you know, if you wanted to kind of look at this, if there's a hole here, right, it's still the same concept, right? So that's actually better. You know, a better way to look at it. But so as x approaches 4, we see we have 2. So the value of 2. Okay, so now as x approaches 6, we'll go ahead and look over here. There's really nothing going on. It's really kind of skips here. So it's really going this way, it's going this way. There's no value being approached, so it does not exist. And for this final example here, we have the limit as x approaches 5, right? We're kind of going back, but it's whatever. So we have the limit as x approaches 5. Once again, only one side does not exist. So what if we had the limit as a function approaches 7.5? Now this is assuming that, you know, because we can see this goes infinitely to the right, and this is 7.5. We can assume that this 7.5, like maybe like around here. This one, it would work, right? Because the function behaves towards that point. So this would equal to 2 as well. And that's basically the gist of it when it comes to graphs like these. Later we'll actually be solving them with actual functions instead of just looking at the graph. And we'll use algebraic techniques and different methods that you might be familiar with, and I'll make a video on that soon. But that is the introduction as it comes to graphs like these, and seeing how it works, how limits work, the fundamental concepts. So we can go ahead and get rid of that, right? Get rid of that. Okay, now we are going to be looking at limits and how they approach values only from one side. So one-sided limits, that's what I talked about earlier. So the limit, let's say as x approaches -2 from the left, okay, of f of x equals, right, it's approaching it from the left side here. As you can see, there's nothing approaching from the left side, so it does not exist. However, we do the same thing, right? Limit, let's kind of fix that here. Limit as x approaches -2 again, and you want to use a plus sign this time to indicate from the right side, of f of x equals, right? And we see this, you see this arrow right here, is from the right, it's approaching this value of 1. So from the right, it does exist. So as you can see earlier in the video, we had the limit in general as x approaches 2, right? Not from one side, but just as x approaches 2. We said it does not exist. So it's safe to say that if, you know, we have it from the right, it is approaching one side, and the left, it does not. It's safe to say if they do not approach it from both sides, right, a certain value, it does not exist. And I'm sure you've, you know, maybe caught on to that already. So now we can do another example. You know, let's try let's do the limit as x approaches, let's do 3, right? 3 from the left, so from the left side it approaches 1, from the right side it approaches 2. So limit as x approaches 3 from the right side, limit as x approaches 3 from the left side, right, for f of x. Right? So from the left side it approaches 1, so we have this minus sign, so that's from the left side 1, and from the right side it approaches 2. So they approach 2 different values. Even though they both approach a value, they do not equal each other, right? So they're approaching 2 different sides. So they're, in general, right, we're talking about the limit as just as it approaches 3 does not exist because they don't approach the same value. So let's do one more example here. We can do, let's do 7, right? You know, at this point, it's kind of just practice now because we kind of did an example like this already, right? So 7, as it approaches from the right, it's 2, right? So you can see it is approaching this value from the right, 7, right? Don't get tripped up by this. This is just saying it's infinitely going to the right. But if we're just looking at this point right here, we're seeing as it approaches 7, right? From the right, it's 2, and then from the left, let's just say limit as x approaches 7 from the left of f of x does not exist. So the limit in general just does not exist. We're not going to write it all out, but you get the point. So there we go. In future videos, I'll be going into more detail on, you know, algebraic techniques for actually solving limits, and when the function is actually given to you and it's not kind of just like looking at this graph. So yeah, be on the lookout for more things. I'll be going to more depth and onto new topics. And don't forget to like and subscribe, and thanks for watching.